Let's look at big F that goes from R cubed to R. And so I'm going to represent R cubed as being x1, x2, x3. So I could have big F of x1, x2, x3 is equal to 7x1 squared plus x2 plus x2, x3. And the way that you evaluate one of these, when you have a vector to plug in, 2, 3 pi would be 7 times 2 squared plus 3 plus 3 pi. And then whatever that comes out to, you just plug in the numbers, the x1, the x2, and the x3, where they would go in the formula that we're interested in. We're looking at functions that go from some vector space Rn, in this case n is 3, to the real numbers. Can a function take something that is not a number as input? So can you have a function that takes functions as input? I'm going to have something called eval at 0. And the domain of eval at 0 is all functions from R to R that are defined at x equals 0. And the codomain is just the real numbers. And the rule is your input is a function f of x, and your output is f of 0. So I can envision that I have something like g of x equals x squared plus 1. What would eval at 0 of g be? What do you get when you plug in 0 for x? 1? I need to think of something. I was going to do e to the x, but it would also be 1 at 0. So let's look at h of x, I x squared plus pi. What would eval at 0 of h? What you're doing to get the answer is you're plugging in 0 into the function, and you get pi times 0 squared plus pi is pi. This is a perfectly valid function in its own right, but what I want to emphasize here is it takes in functions and then it returns a number. I could have another function which is integrate from 0 to 1. The domain, so all functions from the reals to the reals, for which the integral from 0 to 1 of f of x dx exists. Codomain will still be R. You input f of x and you output the integral from 0 to 1 f of x dx. Because you told me what the input is, what legal inputs are, what legal outputs are, and what the rule is, this is a perfectly valid function. Get ready to practice some calculus 2. We'll do easy calculus 2. So what is, we let f of x be x squared. What is integrate from 0 to 1? It's 1/3. Because we have the antiderivative 1/3 x cubed. Plug it in and evaluate at the boundaries by fundamental theorem of calculus. So we get 1/3 as the final answer. This would be the value of integrate from 0 to 1. So there's absolutely nothing that says your function has to take in numbers, output numbers. It can take in functions. It can take in vectors and output numbers. It can take in functions and output numbers. It can take in numbers and output function. So let's look at another function we could do. We have the domain be R cubed. We can have the codomain be polynomial functions from R to R, and the rule would be A, B, C gets mapped to the function f of x equals ax squared plus bx plus c. It's natural because things in R3 have 3 numbers, and quadratic polynomials have 3 parameters that define them. So it's natural to think about if I have 3 numbers, I can turn 3 numbers into a quadratic polynomial pretty easily, right? So our goal here has been just to kind of loosen up our brain about thinking about what functions are